So welcome back everyone. In this part we are going to be talking about the different types of CSMA, including one persistent CSMA, P persistent CSMA, non-persistent CSMA, and O persistent CSMA. So the first one persistent CSMA, what's it? This is basically, you can say the following about it. Before sending the data by any node, the station first listens to the channel to see if anyone else is transmitting the data at that moment. If the channel is found to be idle, the station transmits a frame. Yes, let's say a computer node has data that it wants to transmit, and it first senses the channel. The channel is idle, no carrier, no energy in the medium, and therefore it gets to know that I can transmit my data now. The station transmits a frame. If busy, then it senses the transmission medium continuously until it becomes idle. So let's assume that it senses the channel medium and finds it to be busy. It doesn't wait, let's say 1 second, 2 seconds, or 3 seconds, or certain period of time, and then resense again. If it's busy, it keeps continuously sensing. So usually this is not a clever way of sensing the channel, because if the channel is busy, and you should keep in mind that if something is if a transmission process is taking place, this transmission process usually has a certain time until it gets complete. So it doesn't make sense to keep continuously sensing the channel when you already know from the first trial of sensing that the channel is busy. Wait a little bit. But this protocol unfortunately was developed without considering this phenomenon, and therefore it's not that efficient. It doesn't make sense to keep sensing if you find it busy from the first sensing trial. So this is the main thing that I want you to know about this protocol. It continuously, if it senses the channel and find it to be idle, find it to be busy, it doesn't wait a little bit of time until it senses again. It just continuously keeps sensing before waiting for the transmission to be finished, or the nodes to finish sending their data, or anything like this. Since the station transmits the frame with the probability of 1 when the carrier or channel is idle, this scheme is called as one persistent carrier sense multiple access. So whenever it feels the channel is idle, it's just send it immediately, like pure aloha, with probability equal 1. And therefore they call it one persistent. So one is, see the naming, why we call it why people name it this way. Persistent means continuously sensing the channel if it finds it busy from the first trial of sensing. This is what we mean by persistent. One means if it finds it idle, it transmits with probability of 1. The propagation delay has an important effect on the performance of this protocol. So what else has effect on the performance of the protocol? Here we have the longer the propagation delay, the more important this effect becomes and the worse the performance of the protocol. So why is this happening? The propagation delay has an important effect on the performance of the protocol. As we said earlier, the carrier sense, the one persistent carrier sense multiple access, sense with a probability of 1 whenever it feels that the channel is idle. But usually we already know that the propagation delay of some other packets can affect and can collide with the packets that are transmitted by the one that's doing one persistent CSMA. Because by the time of sensing the channel and find it idle, another channel might be just right now preparing to transmit its data, and because of propagation delay, the node was not able to sense and find whether the medium is busy or not. And therefore, the longer the propagation delay, the more collision you will get and the worse the performance of the protocol. So this is one important issue. So this is related to one persistent CSMA.